Today is our lecture on biased clipper circuits. Dear students, in previous lecture we discussed unbiased series clippers, and in today's lecture we are going to discuss biased series clippers and its types. Biased series clippers basically used to produce clipping at different voltage levels as shown in the figure in the slide. There is a battery named V bias is added in series with the diode to produce a combination clipper as shown in figure. The voltage across the series combination means V bias plus diode voltage must be greater than V bias plus zero point 0.7 volt in case of silicon, V bias plus 0.3 volt in case of germanium, but in this case we use silicon diode, so V bias plus 0.7 volt. This is a series combination before the diode becomes sufficiently forward biased to conduct. For example, in this case, if you see the bias V bias level is set at 4 volts, means 4 volts is a reference voltage or a fixed voltage, then the sinusoidal voltage at the diode's anode terminal must be greater than V bias means 4 volt plus silicon diode 0.7 volt is equal to 4.7 volts for it to become forward biased. Means if it is 4.7 volts, then the diode becomes forward biased. Any anode voltage levels above this bias point are clipped off. In this case, in bias series clippers, any voltage levels above this bias point are clipped off. So now in this slide we discuss different types of bias series clippers which we discussed today. So there are generally two types: biased negative series clippers and biased positive series clippers. In both the types, as you see in negative series clipper, the negative portion is clipped by this circuit, and in positive series clippers, the positive portions clipped by these circuits. Now let's start with the biased negative series clipper. In our previous lecture, we studied unbiased series clipper circuits and their types. And now in this lecture, we are going to study biased series clipper circuits and their types. So first of all, dear students, what is biased means? What is a biasing? What is a biased voltages? What is V bias? It means that we are using a battery or any reference voltage or using any fixed voltage battery in series with the diode combination as we see in the previous slide in this clipper circuit. Suppose VB is the biased or fixed voltage of the battery is used in this biased series clipper circuits. Now biased series clipper circuits depends on that battery either shifted upward or downward, depends on the type of biased series clipper circuits. It means shifting upward or downward depends on the different types. So let's see these different types. We try to understand the operation of biased negative series clippers by using two cases. Case number 1. In this case, the first most important step is to check the polarity of VB. which is a biased voltage or a fixed voltage battery connected in series in this clipper circuit in figure number 3. Now check the polarity of the VB. The upward terminal is positive and the downward terminal is negative. So if you will observe according to the diagram or figure, the upward positive polarity is same like the polarity at the output side, at the load side in the given circuit diagram number 3. So this helps us to draw a or mark a positive 5 volts as VB is equal to 5 volt in figure number 2 in the positive half cycle as shown in the input sinusoidal signal. So first and the basic thing is that where we marked VB in the sinusoidal signal. So in biased negative series clipper we marked VB is equal to 5 volt in the positive half cycle. Why? Because the upward polarity is positive in this case. In this slide, now if the upward polarity of the VB is positive, then mark the VB at the positive half cycle of bias negative series clipper as shown in the figure number 1. VB is equal to 5 volt in the positive half cycle, and if the upward polarity of the VB is negative, then mark the VB at the negative half cycles of the bias series clipper. So this is the first point, that where we should mark VB. So in this case, bias negative series clipper, we mark VB is equal to 5 volt in positive half cycle because the upward polarity of the VB is positive. Now consider case number 1. Step number 1. The first condition in this case is when VI is less than VB, it means we are considering or pointing the portion which is below VB. As the condition is VI is less than VB. So what is VI? VI is 10 volts. VI is 10 volts and VB is 5 volts. So it means the area which is 5 volts, VB is equal to 5 volts, definitely this area or portion is below the VB as shown in the figure. So there are two portions. First one is in some portion in the positive half cycle as the arrowhead shows in case number 1. If you see the red arrow pointing some portions of the positive half cycle, and the other portion is in the complete negative half cycle, which I also mentioned in the figure number 1 with red arrows in the negative half cycles, complete negative cycles, as clearly mentioned in this figure. Now in this case, suppose we apply VI is equal to 10 volts and VB is equal to, which is a fixed biased voltage battery, is equal to 5 volts, which is already marked in the positive half cycle. And in this case VIB is less than VB, means VI is less than 5 volts. As we know that if the voltages at anode side of the diode is greater than the cathode side, in case of silicon more than 0.7, in case of germanium 0.3, then diode conducts and forward biased. But if the anode voltages are less than the cathode voltages, then diodes acts as a reverse bias. So it is clearly mentioned in figure number 2. Now in this case number 1, anode side is at lower potential and cathode side is at higher potential. So 4 volts is at anode side and 5 volts as shown in the figure at the cathode side. So At the higher potential there is a less volts, 4 volts, and at the lowest potential there is a 5 volts. Means now the cathode is at the higher potential and anode is at the lower potential. So in this case 4 volts is less than 5 volts, so the diode acts as open circuited as shown in the figure 3. But I also mention in figure number 2 there is a condition for forward biased. When we apply 5 volt at the anode side and 3 volt at the cathode side, so it means that there is a difference between anode and cathode voltages. Means if the anode voltages is greater than the cathode voltages, then diode become forward biased and short circuited. But in this case number 1 of biased negative series clipper, we apply 4 volts at the anode side and 5 volts at the cathode side. These, why at cathode sides there is a 5 volts? Because the battery upward terminal is positive, so these plus 5 volts appear at the cathode side due to VB, but at the anode side the voltages are less than VB. It means it is a condition VI is less than VB, so we apply 4 volts at anode side. So that's why the diode gets open circuited and acts as a reverse bias as shown in this slide. Now the diode acts as an open circuit, so all the voltages at VB, which is 5 volts, appear at the output terminals. Due to this VB, which is greater than VI as condition in case number 1, so the diode D acts as a reversed bias and act as an open circuit as shown in the figure. Now what is the output? At the output side, polarities of VB and output voltage Vout both are same, so all the voltages at the VB appears at the output side, that is Vout. So Vout is equal to VB and VB is equal to 5 volt, so Vout is equal to 5 volts. Now consider case number 2. Apply condition. Now V input is greater than VB. This is step number 1. Means VI is greater than VB. As shown in the figure below, I also mentioned case number 2 with the black arrowheads pointing the VI is greater than VB. In this case, it means now we are considering or pointing the portion which is above the VB, and VB we marked at 5 volts in the positive half cycle as shown in the input sinusoidal waveform in this figure number 1. So now considering only one portion or some portion that is only in the positive cycles which is above the VB as clearly mentioned in the figure. Now in this case number 2, suppose we apply VI is equal to 10 volts and VB is equal to 5 volts. It means the value of VI is greater than 5 volts. As we know that if the voltage is at the anode side of the diode is greater than cathode side, more than 0.7 in case of silicon and 0.3 in case of germanium, then diode conducts and forward biased. But if the anode voltages are less than the cathode voltages, then diode acts as a reversed bias. So in this case it is clearly mentioned in figure number 2. Now anode side is at higher potential and cathode side is at lower potential. So when we apply 6 volts Why we apply 6 volts? Because Vi is now greater than Vb and Vb is at 5 volts, so we apply 6 volts at anode side of the diode, and at cathode side there is a 5 volts due to Vb, because due to positive Vb these 5 volts appears at the cathode side. So now in this case 6 volts are greater than 5 volts, means anode is at higher potential than the cathode side, so the diode acts as a short circuit as shown in the figure number 2, which is very clear. Now the diode acts as a short circuit due to the condition V in is greater than Vb, so all the voltages at V input appears at the output side at V out due to this condition in case number 2, and in this case diodes acts as forward biased and acts as a short circuit, which is clearly mentioned in the figure. Now at the output side all the voltages at Vi appears at the output side, so V out is equal to V in, it means V out follows V in. Now let's see the output waveform after applying both the conditions in biased negative series clipper. In case number 1, the output voltage is equal to the battery voltage Vb. In case number 2, the output voltage follows V input. So in this figure, first see the input waveforms represent both the cases where Vb is shown as constant fixed DC voltage, which is marked at the positive half cycle because it is a biased negative series clipper due to its polarity, because its upward polarity is positive, so it is marked in the positive half cycle. Now the second thing is the areas which are pointing in this input waveform, V input waveform, according to the cases 1 when Vi is less than Vb with the red arrows, and according to the case number 2 which is Vi is greater than Vb with the black arrows, which is pointing the areas. So at the output waveform in the case number 1 representing the input areas, case number 1, when Vi is less than Vb, as V out is equal to Vb is equal to 5 volt DC fixed. So at the output side, in the downward side, there is an output voltage waveform which represents the fixed VDC of the case number 1 when Vi is less than Vb. So the output is 5 volt, it is constant or fixed at 5 volt. So the areas with the red arrows at the output side, V out in waveform represents with the red arrows. It's a straight line. This is a DC which represent the areas with the fixed 5 volts. And now in case number 2 is representing the input area during case number 2 when Vi is greater than Vb. At V out it is represented by black arrows as V out is equal to V in. In this case some portion of the positive half cycles follow the V in at the V out, means output is following V input. So at the output waveform same input is repeated at the output side. So this is the output waveform after case number 1 case number 2 with conditions in biased negative series clipper. So it is the biased negative series clipper that depends on the battery. It clips the negative half cycle and there is some shifting in the voltage level due to the biasing voltages, means that depends on the battery. Now this is a second type of series clipper. These are biased positive series clippers, and we try to understand the operation of biased positive series clipper. Now again by using two cases with two different conditions. In case number one, in this case, the first most important step is to check the polarity of VB, which is a biased voltage or a fixed voltage battery connected in this clipper circuit in series. Now check the polarity of the VB as shown in the figure below. The upward terminal is negative and the downward terminal is positive. Also in this case, the direction of the diode and the battery is opposite than the previous case in biased negative series clippers. So if you will observe according to the diagram, the upward negative polarity is opposite to the positive polarity at the output side. This is also one difference in this given circuit diagram. So this helps us to mark VB. Now the first important step is that where we marked VB. So in this case we marked VB in the downward side. So draw a negative 5 volts as VB is equal to minus 5 volts in the negative half cycle as shown in the input sinusoidal signal in figure number 2. Now in this case the upward polarity of VB is negative. Then mark the VB at the negative half cycles of the biased positive series clipper as in figure number 1. Let's start. Consider case number 1. Step number 1. Vi is greater than VB. When Vi is greater than VB, it means we are considering or pointing the portion which is above VB 5 volt. For example, VB is equal to 5 volt marked downward as shown in the input sinusoidal waveform in figure number 1. Now this time in positive series clipper this VB is equal to minus 5 volt. So there are two portions. First one is in complete positive half cycles as shown in the figure, which is above the VB and VB is minus 5 volt, and the other is some portion is in the negative half cycles above the VB as clearly mentioned in this figure number 1. Now in this case number 1, step number 1, Vi is greater than VB. Suppose we apply Vi is equal to 10 to minus 10 volts and VB is equal to minus 5 volts, which is already marked in the negative half cycles in figure number 1. As we know that if the voltage is at anode side is greater than cathode side, more than 0.7 in case of silicon and in germanium 0.3, then diode conducts and forward biased. But in this case anode voltages or at anode side voltages are minus 5 volt. Now the direction of the diode is opposite and at the VB side minus 5 volts will appear at the anode side in figure number 2, which are less than the cathode voltages, because now cathode is at minus 4 volt due to the condition, because the condition is Vi is greater than VB. Then diodes acts as a reverse bias. So it is clearly mentioned in figure number 2. Now anode side, which is minus 5 volt, is at lower potential, and cathode side, which is at higher potential, which is minus 4 volt. So that is minus 4 volt is greater than minus 5 volts. So the diodes acts as an open circuited as shown in figure number 3. Now the diode acts as an open circuit as shown in the figure. So all the voltages at VB, which is minus 5 volt, appears at the output terminals. In this case, number 1, when Vi is greater than VB, the diode D gets reverse bias and acts as an open circuit as shown in the figure. Now at the output side, VB is equal to minus 5 volts, means the voltages at the battery side shifted to V out. So all the voltages at VB appears at output side, that is V out. So V out is equal to VB and VB is equal to minus 5 volt. So V out is equal to minus 5 volt. Now this is case number 2, and we are going to apply the condition Vi is less than Vb. When Vi is less than Vb, it means now we are considering or pointing the portion which is below the Vb. For example, Vb is equal to minus 5 volt, marked downward as shown in the input sinusoidal waveform in the figure number 1. So now considering only some portion of the negative half cycles which is below the Vb, as clearly mentioned in the figure below. Consider case number 2, when Vi is less than Vb. Suppose we apply Vi is equal to minus 10 volts and Vb is equal to minus 5 volts. In this case, Vi is minus 10 volts because we mark Vb is equal to minus 5 volts in the negative half cycles due to the polarity of the Vb is negative, so we mark it in the negative half cycle, and it is also a biased positive series clipper. So in this case, the value of Vi minus 10 volts is less than minus 5 volts. As we know that if the voltage at anode side of diode is greater than cathode side, more than 0.7 volts in case of silicon and 0.3 volts in case of germanium, then diode conducts and forward biased. But if the anode voltages are less than the cathode voltages, then diode acts as a reverse biased. So in this case, it is clearly mentioned in figure number 2. Now anode side is at higher potential, which is minus 5 volts due to the battery voltages Vb minus 5 volts that appears at the anode side, and the cathode side is at lower potential, which is at minus 6 volts, that is due to the condition that Vi is less than minus 5 volts. So minus 6 volts is less than minus 5 volts, so that the diode act as short circuited as shown in figure number 2. In this figure, the diode acts as short circuited. Now the diode acts as a short circuit due to the condition Vi is less than Vb. So all the voltages at Vi appears at the output side at V out due to this condition. Vi is less than Vb, then the diode D gets forward biased and acts as a short circuit as shown in figure below. Now at the output side, all the voltages at Vi appears at output side, that is V out. So V out is equal to Vi. It means V out follows V input. Now let's see the output waveform after applying both conditions as case number 1 and case number 2 in this series clipper. In case number 1, V out is equal to Vb, and in case number 2, V out is equal to V in. Input waveform represents both the cases where VB is the constant fixed DC voltage is equal to minus 5 volts as shown in both waveforms. At the output waveform in case number 1 is representing the input area. During case number 1 Vi is greater than Vb as V out is equal to Vb is equal to minus 5 volt fixed DC, and case number 2 is representing the input area. During case number 2 Vi is less than Vb as V out is equal to Vi, means output is following input, so at the output waveform same input is repeated at the output side, which is clearly mentioned in the output waveform graphs. After this video lecture, students now able to understand the complete operation and working of bias series clippers and also its types, namely biased negative series clippers, biased positive series clippers. Due to biased voltage or fixed battery, the output is either shifted at positive side or negative side, depends on the type of clipper circuits. Students can now able to design any type of clipper circuits. Also they can solve different types of related problems to these circuits.